Number 15. Which type of discontinuity, if any, occurs at x equals 3 for the equation here for f? Well, remember, discontinuity occurs when the graph does not exist. Okay, so this would mean that something does not exist. Now, as I look at this problem, I know in mathematics you're never allowed to divide by 0. So if I plug in x of 3, let's just test this real quick. What is 3 minus 3? It's 0. Are you allowed to divide by 0? No. So I do know it does not exist. So it is discontinuous. Now, what type is what we got to discover? The way to discover is to see if you can somehow remove that value from the equation. I know it's not jump because this is not piecewise equation. So it's either infinite because it's either infinitely going to be there, or it's removable if we can remove it. So how do we check? Well, we need to see if we can simplify this factor or cancel this factor out. How do we do that? We need to factor the top. I'm going to do my x method, so I'm going to say that's a, b, and c. And so x method, you do a times c for the top of the x, which would be 1 times negative 15. Again, negative 15. Put 2 on bottom. Now you go through your factors. Would 1 and 15, do they multiply to be the value of 15? Do they somehow add or subtract to be 2? No. So I go on. 2, that would be 2 and 7.5. We don't do decimals, so what about 3 and 5? Let's try those terms. Could I somehow have a difference of 2? Yes. If I had 5 minus 3. Does that now give me negative 15? Yes. So now, since this a is 1, remember what you do is you're going to take this power here and you break the power in half. Since the a is 1, it won't simplify. This is great. So instead of being x squared, it becomes just x. So we have x minus 3 times x plus 5. All this is over x minus 3. Notice now what happens to my equation f of x. If I wrote it this way, the first thing I would do is I would simplify that out and say that it's the same thing as x plus 5. Well, that's not totally true. Why? Because I removed this value, and so for the domain, you would have to say that x cannot equal 3 in my domain. But since I removed it, that is a value that's a removable. So we have a removable discontinuity because we could remove it from the equation. At x equals 3. And there's our answer. Now let's check this in the graph. If it's removable, we should not be able to see it. It's almost like the calculator when they graph it. It graphs it so fast it'll remove it. Let's check. So I go over here. And on my graph, in the numerator, we had x squared plus 2x minus 15. And this is over x minus 3. Okay, graph, and it looks just like that equation of x plus 5. They look exactly the same. Well, what's the difference? If you went Control T, you'll notice that the first one is undefined at 3. Just like we said, it has removable. You cannot see it there. So let me screw it up a little bit. Where x is 3, you cannot see it, but it is in fact removable there. And here's where the value would be. It's approaching 8, but it's actually undefined.